Hi, everybody. Welcome to another excellent doc talk here today with the CTO of Plural.sh, Michael Guarino. Very nice to have you with us today. How are you doing, Michael?
Good. How are you?
Good. So what we wanted to talk about is an amazing blog post that came out not too long ago titled "StatefulSets are broken." And obviously the data on Kubernetes community, when we talk about Kubernetes features and the things that make running data on Kubernetes possible, stateful are a very prominent figure in that conversation, whether we're talking about stateful, whether we're talking about persistent volumes, whether we're talking about different features regarding networking, different things that are involved in that area. And Plural has pointed out some of the things that perhaps might be lacking there. So Michael, I just want to know a little bit of background about your Kubernetes experience, data on Kubernetes experience, and where this idea came about.
Yeah. So just for some context, what Plural does is we make it very easy for you to run a lot of complicated open source tools on Kubernetes. So things like Airbyte, Airflow, Superset, there's about 40 or so of them. And a lot of them actually do have a stateful workload underneath. So the most common is a Postgres database, but then there's a whole host of others. Prometheus, for instance, is very commonly deployed. So we've interacted with a fair number of different ways to try and make stateful workflows work on Kubernetes and the pitfalls that come with that. Before Plural, I've had experience in Kubernetes working at frame.io, and then general distributed systems background at a number of other companies like Amazon, Twitter, and Facebook.
Okay, household names that we might be familiar with. With that in mind, for developers out there that might not be super familiar with StatefulSets, what are the capabilities? What are the techniques or advantages that they give to developers?
Yeah, so it gives a number of things. The first one, the most important, is persistent volume automation. So for each pod in the stateful set, it will mount an appropriate persistent volume unique to that pod. If a pod is restarted, the persistent volume will be remounted to the new node that the pod is restarted on. But then it gives some other things that are oftentimes pretty useful for stateful workloads, like deterministic network address. So it's usually pod name -0, pod name -1, up to pod name -n. And then some other like networking guarantees that improve it. The last thing is it's a very deterministic rollout policy. So it will always, when you decide to upgrade a stateful set, change its image or something like that, it will always delete or replace a pod in a specific order. So if for whatever reason you have a more delicate workload, something like Zookeeper maybe, that might have something break in a consensus mechanism, it will help. It'll help keep that relatively sane. Whereas something more like along the lines of a normal deployment that can take out like half the nodes at a time or do more aggressive rollouts, it might not be appropriate.
All right. With that in mind as well, too, for a lot of folks out there that are SREs or becoming SREs, what does this mean in terms of the impact it might have on high availability?
So I think there is some trepidation around stateful sets on Kubernetes. That's really unwarranted. So you'll obviously be able to have multiple replicas for your workload with it, because you can specify any number. Some things like databases, you'll have to have a layer on top of the stateful set to do replication for a master slave failover or something like that. But the big thing is the persistent volume automation. So if something were to break, that the concern would be like, do I lose that data, or is there some potential for data loss? And Kubernetes built-in persistent volume CSI driver and everything like that will just it does it completely transparently for you. So there's really nowhere near as much of a concern. And I think actually people will start learning more and more that this is actually a very powerful tool. And it makes, to some degree, a lot of the high availability techniques with other databases kind of unnecessary, because you can just trust that the stateful set will restart that pod and figure out how to get the data underneath it in really, really quick order. So
I think that's a really big point, because a lot of people, like you said, a certain trepidation of, well, what happens if I lose my data, mission critical workloads? What's my backup and
Yeah.
restore going to be looking like? So no, I think that's a really good point
Yeah.
to help people sleep better and not worry about being on call as much, things of that
Yeah.
nature. With that in mind, then, so obviously, StatefulSets came around a few years ago. Considering, how Kubernetes has progressed, what are the things that you have identified at Plural that might be sort of missing from them that could be added, things that we could be expecting in the future?
Yeah. So what we highlighted in the article, and this is, I believe, really the only big wart in the stateful set controller at the moment, is the support for a resize of the underlying volume is not there at the moment. And so if you think of like the various lifecycle actions that need to happen with a stateful workload, it's really just scale out and scale up. And it's very easy to scale up for CPU and memory, but as you accumulate more and more data, you'll oftentimes need to also expand the underlying volume because it will fill up. It takes a while oftentimes, but it does happen, especially if you want to be like, parsimonious with the amount of disks that you're giving to the workload. And so like, if you're thinking about the operational capability of like using a stateful set for a production workload, and then you realize it's very, very hard to, or like very clunky. It's not necessarily hard, it's just clunky to resize the volume. Then that's a big concern. The other thing, and this was where it becomes more tricky, is interaction with operators. So if you open up the code base of a lot of operators that ultimately do schedule stateful sets, the Zalando Postgres operator is a really good example. They actually work around this limitation and do the common procedure to resize a stateful sets volume, which is basically self-deleting the stateful set that keeps the pods around, figuring out how to resize the underlying PVCs for all of the individual pods, and then recreate the stateful set on top. And it figures out, oh, there's these pods already living. I'll just take control over them and go happily ever after. The problem is there's a number of operators that don't actually do that, and they just haven't written the logic for it. And it's very, very difficult to then get the stateful set to resize this volume, because the operator will very quickly recreate the stateful set when you do the soft delete mechanism. The Prometheus operator is the most annoying of these, because I don't believe that they have any support for it at all, and haven't really planned to do so. And that's a very widely used operator, obviously, and we actually use it a lot in our clusters as well. And it's kind of frustrating that you theoretically could have to take data loss to resize your Prometheus instance, because you can't scale the underlying volume because of that operator stateful set interaction issue.
And once again, like you said, regarding, estimations, or thinking about day two operations, that kind of trepidation that might come in there of, well, if we're gonna have to go in there and manually, and also anticipating data loss and how that's going to be affecting different, agreements or objectives that have been set out by the platform team. One thing, that can be a bit of an obstacle, and something that people won't be terribly excited about handling, I guess. With another thing that that's mentioned here is the element of CRDs. I ask this because it's been frequently mentioned by some community members that it's their favorite feature on Kubernetes. Is that something that you would agree with, or why do you think that might be?
It's definitely a really powerful thing, right? It's because you can encapsulate a lot of complicated complicated automation into an independent controller that's just declaratively defined with the CRD. The problem is, again, is the onus is on the developer of that operator to make sure that they cover all the operational edge cases. And I think the reality in the community is a lot of these operators are kind of half built. At least that's what we've sort of seen going around through. That's probably just an artifact of immaturity. Like, people are still learning about Kubernetes. It takes a long time to build these things, a lot of battle testing. But like, especially, I don't want to pick on the Prometheus operator because they do a lot of things really, really well. But like, that's a pretty huge flaw in the operability of that. So yeah.
No, I think it's a great point. With that in mind as well, too, with operator maturity, is that it's literally a question of hours, that there needs to be more time spent on these things to get them up to speed, or is there something else that perhaps is being missed?
Yeah, that's a good question. I mean, it's probably just the reality is it's probably just, it's not like enough dedicated resources spent to developing a lot of them. The cases where they're kind of rough is like you have an open source company that's kind of thinking about Kubernetes, spends like a few months trying to build an operator, but then leaves it abandoned. So there's a few cases of that. The really prominent ones that are clearly being used in the community very widely tend to be very high quality. Like we use this on a Postgres operator all the time, and it's pretty amazing how much capability it has. It's not an easy thing to do at all, and it's all completely open source and freely available. So that's pretty amazing. But it's just, there's a lot of them out there. There's probably thousands at this point, and the reality is there's going to be a long tail of ones that are mostly unmaintained, and that's just the way it is. But you can easily tell whether that's the case or not. You can just look at the GitHub repository, check the stars, check the commit history, and see, okay, this is definitely actively being managed, and go from there.
Yeah, no, I hear you on that. One of our first guests actually in the first 10 live streams that we did was Alexander Kukushkin from Zalando, who was at Zalando, and hearing about all his work. And so having him back and seeing the updates on them, but like you said, there's a vibrant interest on there that keeps going. And so that's going to be very relevant in terms of how the importance, the role that these operators are going to be playing, and how much value people are getting from them. I guess what I want to finish with is, given what we've seen, up until now, what are the challenges that you think that we can pose to our community, the Data on Kubernetes community, when it comes to answering the questions that have yet to be answered, or looking into things that perhaps haven't been explored? What would you like to see the Data on Kubernetes community do regarding this particular challenge of StatefulSets?
So there's been a longstanding issue actually to fix this in Kubernetes. And I believe there's actually a pull request that was just recently opened. Maybe the blog post actually sort of kicked them in the pants. But it's honestly something that should be relatively easy to fix in Kubernetes itself. So, maybe upvoting that issue, or it sort of helping encourage the Kubernetes maintainers to push it over the line might be the best thing to do. Once it's there, the problem completely resolves. And honestly, StatefulSets should be pretty feature complete for like what they're supposed to be doing. So that would really be the only thing I could think of.
That's good. That's reassuring, because it's a relatively simple path. I mean, once again, it's a question of time, being in touch with the right people. Obviously, things like the article open people's eyes, like you said, maybe got some folks into that pull request. So that's healthy. These conversations need to happen. If not, things are going to stagnate, and we're not going to see the progress. And like you said, tools that are as used as Prometheus, like having flaws of that kind. Obviously, there's a lot of attention that goes into other areas, which is why it's always a balancing act. But I think it's a good way of making people aware, and that's what community is about, is having a space where we can talk about these things in a vendor neutral environment, where just trying to help folks navigate these day two operations, making things easier. Anything else you want to mention before we wrap up? Anything else new going on at Plural we should know about?
So one of the more recent things that we've released is basically reusable stack. So you can now run the Plural stack install like data command and get a full data stack all at once on Plural. And we're curating these use cases based on what we think the ideal set of applications for that use case is. In the case of the data stack, it's Airbyte, Dagster, and Superset, I believe, as the three main components. But we'll continue trying to figure out the appropriate things and just make it really easy for people to go from zero to like production ready, the full production ready infrastructure for a lot of these engineering functions as quickly as possible at the lowest cost as well. So, using open source, using the cloud provider at the compute level instead of its managed service tier and everything like that. That's our primary goal.
Very good. So never a dull day in Plural. And looking forward to hang out with you folks in KubeCon. Michael, thank you so much for your time today.
Yeah, thanks for having me. I definitely appreciate it.
Absolute pleasure. All right.